If we need to do a computation, which tool would be best for the job?
To do a computation, do I want a computer or an abacus? Really no brainer, Laura.
You sure about that?
Computation, computer. Yeah, I'm sure.
Okay.
I think I'm sure. Oh, wait, maybe...
You've made your choice.
This is the Qubit Lab. Every computer is the same.
And this abacus is just as powerful as that overblown bean counter.
According to computer science. But you can't play StarCraft on an abacus, so...
When a computer scientist compares two machines, they don't care about speed. Or whether you can ask Siri to tweet about Facebook. Or if you're just one huge gaming nerd. They just count the number of steps needed to make a calculation. This is roughly the same for my abacus as Heath's laptop, so they are just as powerful.
But are there machines that are really more powerful than an abacus? Not just faster, but more efficient?
Yes, quantum machines.
Here at the Qubit Lab, we like to talk about quantum computers because they offer the power to beat ordinary computers at this challenge.
But you don't need a full-size quantum computer to beat Heath's laptop. You don't even need this. You can start with one of these. This is called a Galton board. Francis Galton realized that dropping marbles onto a board full of pegs would produce a distribution that looked like a bell curve. What if you use quantum particles instead?
Now the distribution you get is very different. If your particles are fermions, like neutrons, you get one pattern.
And if your particles are bosons, like photons in a light beam, you get another pattern.
Recently, two researchers from MIT, Scott Aronson and Alex Arkhipov, showed that the boson pattern is too weird to calculate quickly with a normal computer.
The distribution is given by permanence of submatrices of the transfer matrix. Evaluating permanence is a sharp P problem. That's even harder than NP.
All that jargon just means it is extremely hard to calculate the distribution. But it can be done by sending photons through a chip like this, creating a quantum computation that beats classical machines.
But even if quantum computers are still several years away, the race to build a boson sampling machine has now begun in earnest. Research groups in Australia, Vienna, Italy, and the UK are all sending photons through glass chips to demonstrate a simple quantum machine that will outperform a laptop.
If Aronson and Arkhipov are shown to be right, the supremacy of the abacus might finally be over. I'm Heath.
And I'm Laura. See you next time.
At Schrodcat35, LOL, you are so right. Hashtag quantum mechanics, hashtag first world problems, hashtag FML.
You're tweeting.
Yep.
On an abacus?
Yep.
You're insane.
Yep.